Hello viewers, I'm Kausalya. Today we are going to solve problem number 8 in time response analysis. And the problem is a unity feedback control system has an amplifier gain Ka and gain ratio G of S in the feed forward path. What is a feed forward path? Look at this diagram. The elements which are present in this order, that is which are present in this path, is known as a feed forward path. Here you will be having your input. Here, so this is your input part and this is your output part. The elements which are present between your input and output, okay, that path is known as feed forward path. And a derivative feedback H of S is introduced as a minor loop around G of S. Now we are having a gain K, right? We are having gain K, and apart from that we are having another element G of S. Both these are said to be in the feed forward path. And again we are having a feedback, okay, feedback H of S. Where is this feedback? Around G of S. So this is your G of S. So around G of S you are having a H of S as feedback, right? Can you people understand this? I will show the clear diagram later. Okay, I have drawn here. Just to explain, I am doing this, right? Then determine the derivative feedback constant K naught so that the damping factor is 0.6. That is, they had given the value of zeta as 0.6. We have to find K naught. Okay, that's it. So here you see, when you look at the diagram, as I already explained, we are having a gain and gain ratio. That is, we are having a gain Ka and gain ratio G of S in the feed forward path, right? This is your input and this is your output. The elements which are in between your input and output in a straight line is known as the forward path, right? So these two elements are in feed forward path. On the next line, you see a derivative feedback H of S is introduced as a minor loop around G of S. Now we are having a feedback element H of S around G of S. So this is your G of S, and around this G of S you are having a minor feedback loop, and the feedback loop has an element S into K naught, right? Then find the value of K naught when the value of zeta is equal to 0.6. So we have to draw the block diagram by ourselves. Here, when you look carefully, they had given these two elements as feed forward elements, and we are having this S into K naught as a feedback for this G of S alone, right? So when you look at this, they had given this is a block diagram and they had already given the value of gain as 10, right? So again we have to draw a feedback, that is the feedback is a unity feedback, right? This two also they had mentioned in the problem. You just, when you look at this first line, okay, see the problem here. A unity feedback control system has a gain K equal to 10. So the type of feedback is a unity feedback. This is for the entire control system, right? This is the reason here we have drawn a unity feedback element, right? So as I already said, whenever a unity feedback is given, we should assume a negative feedback, right? Hope you people understand this block diagram well, right? Then our next step is we have to reduce this block diagram, and finally we have to find the value of K naught. That's it. Hope you people are clear with this block diagram reduction. I hope so. Let me explain. Then we can see. So here you see the value of G of S is 1 by S into S plus 2, and the value of this H of S is S into K naught. So this is a feedback loop. We can eliminate this feedback loop by using block diagram reduction rules. So what is the rule? How to eliminate this? The formula is G of S divided by 1 plus G of S into H of S. Since the type of feedback is negative, here we are using plus sign. So just substitute the values here in this formula. So in the place of g of s, 1 by s into s plus 2, and in the place of h of s, we are having s into k naught. So just substitute the values here. When you substitute the values, the next step is we have to take LCM. So when you take LCM, just you have to multiply this s into s plus 2 with this 1 here. So s into s plus 2 plus s into k naught, and the entire terms get divided by s into s plus 2. Now both the numerator and denominator, when you look, the denominator terms, that is the denominator term of the numerator and denominator term of the denominator remains same. So they cancel each other, and finally we are getting an expression as 1 by s into s plus 2 plus s into k naught, and here we are having, when you multiply this term, s into s, s square, s into 2 becomes 2s, and here this sk naught as such, right? So this is the reduced form of this inner loop. So here the thing is, I have redrawn the block diagram. So this is amplifier gain, that is 10. In the place of the loop, I am replacing the final expression, that is 1 by s square plus s into 2 plus k naught, and this unity feedback path remains the same, right? And the next step is here, these two blocks are in series combination. So to combine blocks in series, we just need to multiply. That is the rule. So when you multiply, finally we are having the equation as 10 divided by s square plus s into 2 plus k naught, right? Then the next step is we are having a feedback loop. So we have to eliminate this feedback loop, and the type of feedback is unity feedback. So the value of h of s will be equal to 1. That's it. So just write the formula. As we all know, the formula is g of s divided by 1 plus g of s into h of s. So this is your g of s element, and the value of h of s is 1 because it is unity feedback. So just substitute the values here. So the first step I had substituted the values, and the next thing is we have to take LCM. That is, this term will get multiplied with 1. So when you multiply, again these two terms are same, so they cancel each other, and finally we are getting the value as C of s by R of s is equal to 10 by s square plus s into 2 plus k naught plus 10. Now we are going to compare this expression with the standard format, as we are asked to find a value of k naught. So just substitute. What is the standard format? The standard format is omega n square by s square plus 2 zeta omega ns plus omega n square. So in the place of omega n square, we are having 10 here. So omega n square is equal to 10. So therefore omega n is equal to square root of 10, and finally the value is 3.162 radian per second. The next thing is this coefficient of s, 2 zeta omega n, is compared with 2 plus k naught. So just when you substitute here, again the value of zeta they had given as 0.6, this is given in the problem, and omega n we had find it out as 3.162. So when you substitute this in this equation and finally solve, the value of k naught is found to be 1.7944. That's all. The problem gets over here. Hope you people understand. Thank you.